Alright, still working with absolute values, but now with absolute value inequalities. Again, this is going to be a two-part lesson, so we'll do both parts in this video, but they will be divided based on how they were divided in class. So to solve absolute value inequalities, we actually will change them into compound inequalities. If you need a refresher on compound inequalities, you can look back in your notebook. But in order to solve absolute value inequalities, just like absolute value equations, you will first isolate the absolute value, which, in case you forgot what that means, it means to get the absolute value by itself. So isolate the absolute value. Second, like I said, we are going to create compound inequalities. So we will create a compound inequality. In a compound inequality, you will either have an and or an or. Here is what you have to decide. If you have x, whatever's inside, is greater than your number, let's say a, then we're going to set up an or, where x is less than a, or x is greater than a. A is the number, x is whatever's inside the absolute value. If you have x is less than a, then you are going to set up an compound inequality, which will look like this, where what's inside is in the middle, and you have a negative and you have a positive, but without the absolute value symbols, we need to take those out. One way that I remember this is x is greater. If you have great or, you're going to use or. If you have less than, you are going to use and. That's a good way to memorize which one you need to use. Once you have set it up, step 3, you are going to solve that inequality. So the big part of this is making sure you know how to set it up. So we're going to go ahead and look at number 1 and talk about how we need to set it up. Make this still visible while we're setting it up. Step 1, isolate the absolute value. Notice this absolute value of x plus 1 is already by itself. So step 1 is already done for us. We don't have to worry about that. Step 2 is create a compound inequality. I am looking very specifically at my symbol. That is a less than symbol. So I'm going to use less than. So if you have absolute value of x, in this situation x is x plus 1, and less than a, in this situation a is 9, then we're going to set it up to look just like this. So we're going to take our 9 and make it a negative 9, a less than. Instead of x, we put what's inside. X plus 1 is inside, and positive 9. So negative 9 less than x plus 1 less than 9. I'm going to move this up now so we can see it, because our next step is to solve the inequality. It might have been a while since you have done compound inequalities. When I do these, it sometimes is easier. If you cover up the left side, you might know what you needed to do. So I do at this point, I need to subtract 1. The only difference is I actually need to do it to every piece, because I want x in the middle by itself. Negative 9 minus 1 is negative 10, is less than x less than 8. Once the x is by itself in the middle of an and compound inequality, I have finished. What this actually says is x is between negative 10 and 8. It might have been a while since you've graphed these as well, but we're going to do that too, since it says and graph its solution. To graph these, I'm going to circle both negative 10 and 8. I need to decide if it's open circle or closed circle. Since there is no or equal to, then it is an open circle. And this is x is between these two, so I'm going to shade the line segment in between those two numbers. And that is how I graph those compound inequalities. Okay. So let's open up and look at number 2. If you are watching this to learn this, it's good. I need to pause this and go ahead and try number 2. Number 2 is like the one on the front. It has already been solved for the absolute value is already by itself, so I don't have to worry about that. What I do need to do is set it up. This one is also a less than symbol. So again, I'm going to have an and compound inequality where I take the 4 and start with negative 4, less than, whatever's inside, less than, positive 4. I then am going to move the 7, or so that the n is by itself in the middle. Negative 4 minus 7 is negative 11. 4 minus 7 is negative 3. I'm finished once the variable is by itself in the middle. So I'm going to circle negative 11, and I'm going to circle negative 3. Again, it is not closed circle, it's open because there's no or equal to. And I'm going to shade in between. Okay. That one is complete. Remember, this is the answer, and we were supposed to graph the solution. Let's look at number 3. Number 3, the first step is not done for us. We are going to have to move stuff away from the absolute value so that it's by itself. This is a positive 1, so we're going to do the opposite of that is subtract. I have the absolute value of 6 plus k is greater than 5. I am not looking at my symbol until the absolute value is by itself on one side. Now I have greater. I'm using the steps on the front. I have greater this time. So I'm going to say x is less than a negative number. So 6 plus k is less than negative 5. Or, let's look back at our steps. Or, x is greater than a positive number. So, or 6 plus k is greater than 5. The only difference in this and what I did a few minutes ago is now I have to solve them both, and I have to solve them both separately. So subtract 6. K is less than negative 11. Let's do the same over here. Subtract 6. K is greater than negative 1. We're now going to graph it. So let's graph this one by looking at, we're going to circle negative 11. It is open because there's no symbol underneath. And I'm going to shade to the left because it's all the numbers that are smaller than negative 11. I drew an arrow because it goes on forever. Alright, and k is greater than negative 1, so circle negative 1. Again, it's open because there's no or equal to at the bottom, and shade to the right because it's the numbers greater than negative 1. There's how an or compound inequality looks. Likewise, let's go ahead with number 4. Again, if you're working on this for your benefit, you need to pause the video and try number 4 on your own before you press play. The only way to learn the math is to do it on your own and practice. Then you can press play and make sure you have done it correctly. Okay, we need to get this absolute value by itself, so we're going to subtract 2. Absolute value of r minus 3 is less than or equal to 10. Then I need my two cases. I do have an or equal to this time. That doesn't change how I set it up. It just changes how I graph it. It is less than, so I'm going to use an and, which means I have a negative 10, less than or equal to, r minus 3, less than or equal to 10. Notice I put or equal to because I just match this. That's the only thing that changes about or equal to. Okay, then I'm going to move or add 3 to every piece. And I do have to do it to all of them or it will not be correct. So -7 less than or equal to r less than or equal to 13. Going to now graph it. This piece is done. Luckily, so far we've only had one step inside. That will change. Alright, -7 is between -6 and -8. So open, but it's not actually going to be an open circle. I've got an or equal to, so it's going to be closed. That closed means that could be the answer as well. Then I'm going to go to 13, close it, and shade in between, because and means it's the stuff in between those two. As I have stated, this is going to be a two-part lesson. We're going to finish the last one for this part. We'll start the other part in just a few minutes. If you're doing this on your own, again, pause. See if you can do this one. Okay, last one of this foldable. I have -6 times the absolute value of n divided by 4, which is less than or equal to 12. Remember, if it's sitting right next to something, it is multiplying. So to undo that, to get that absolute value by itself, we're going to divide by -6. Remember, if you are dividing by a negative with an inequality symbol, you have to flip that symbol. If you don't, you will set it up incorrectly. 12 divided by -6 is -2. If you remember from absolute value equations, a negative number kind of seems like a problem. We had no solution when that happened before, but we need to think this through. If we have a something in the absolute value, so some number is greater than or equal to -2, so the absolute value of a number is greater than or equal to -2. If we think about that, any number that we plug in here is going to be greater than a negative because it's an absolute value, which means any number we plug in here is going to make this statement true because it is greater than a negative number. All absolute values are greater than a negative number. So my answer for this one is actually all real numbers. I know it's all real numbers when I have greater than a negative number. We're also going to review that when we talk about the types of solutions in the second part of this lesson. If you wanted to shade that, graph it, it is just this whole line segment, since this is a line segment of all real numbers. We will talk about another special case in the second part of this lesson. The second day of this is not that much different than the first. We're still going to isolate the absolute value first. Then we will create a compound inequality. Then we will solve the compound inequality. We have to move everything away from this absolute value bar. So we need to add 5. That leaves us with 1 plus b is less than or equal to -8. In the last part of the video, you saw where we had an absolute value is greater than a negative number, which is possible. It is not possible for an absolute value to produce a number that is less than a negative number, because that would be a negative number. Therefore, this is not possible. This is no solution. I know it is no solution when I have the absolute value less than a negative number. So we can have a compound inequality with either and or. We can have all real numbers, or we can have no solution. Number 7, again, if you're working on this, you might want to pause your video and try to work it yourself. We have the absolute value of 10 minus 2n, all divided by 3. We need to move this 3 to the other side. By multiplication, so we've got the absolute value of 10 minus 2n is less than negative 6. We have that problem again. We have less than. This one is no solution. Less than a negative number is not going to work out for us. We've got another no solution. Go ahead and open this up and we'll do number 8. We're going to multiply by 3. So the absolute value of 9 plus 8a is greater than negative 12. We have another negative. This one is greater than negative 12, so any number that we plug in for a will work because it is greater than a negative number. So all real numbers will work. When I created this, I did not plan for all of those to come out that way, but that's okay that they did. Let's continue on. Remember, all real numbers you can technically shade. It's just the entire graph. No solutions you cannot, because there is no solution on the graph, as one doesn't exist at all. Number 10, everything away from the absolute value bars. We have a 6, which is, remember, multiplication, so times 6. And we have a minus 5, so we're going to go ahead and add the 5. So we're going to bring the 6 and the absolute value back down. And we have greater than 120. We don't have a negative number now, so I know it's going to be okay. To continue to do this problem, I'm going to divide by 6. So the absolute value of 10x plus 10 is greater than 20. Now I've got one that I can set up again. So from part 1, we had those steps that we're going to do. We first isolated the absolute value. That is done. Now we're going to create a compound inequality. And we have greater, which means we're going to use or. So we're going to have 1 is 10x minus 10 is less than negative 20. And or 10x minus 10 is greater than 20. And then we're going to solve each of these and graph it on our number line. So add 10. So 10x is less than negative 10. Divide by 10. X is less than negative 1. Or add 10 to this one. 10x is greater than 30. Divide by 10. X is greater than 3. My two solutions are listed here. And this is a range of solutions. So I've got x is less than negative 1. The numbers to the left of negative 1 are shaded in. And x is greater than 3. The numbers to the right are shaded in. These, of course, are still open circle because there is no or equal to line underneath. Okay, last but not least, I'm going to move away from these absolute values. So still have 6. Absolute value of 6 minus 7r is less than 6. And divide by 6. The absolute value of 6 minus 7r is less than 1. This one is a less than, so we are going to set it up as an and compound inequality, where I have a negative 1 is less than whatever's inside, 6 minus 7r less than positive 1. I'm going to continue to solve by moving the 6, which is positive, to each piece. We have negative 7 is less than negative 7r is less than negative 5. And I'm going to divide by negative 7. Remember, if you divide by negative, even if it's in a compound inequality, you have to flip the symbols. So 1 is greater than r, which is greater than 5 over 7. I'm going to rewrite that so that I have my smaller number, 5/7, on the left with less than r, less than 1. So I'm going to graph at about 1 and then 5/7. I'm going to go ahead and convert that to a decimal so we understand where 5/7 is. So I'm just going to do 5 divided by 7. And that is 0.714. So it's roughly 0.7. So just less than half here. They are actually not closed in, so I don't need to shade them. So let's fix that. So open circle at 1, open circle at about 5/7, and I'm going to shade in between. So it's a very small area there that we have. Alright, just for a recap, what are the possible solutions for absolute value inequalities? So you could have two compound inequalities. You could have a compound inequality solution. You could have either and or with a range of values for each. You could have a no solution when the absolute value is less than a negative number. I'm going to have to move this. You cannot see it at all. Or you could have all real numbers, or which is or occurs when the absolute value is greater than a negative number. So you could have a couple of different solution types.